Hi, welcome to the EEVblog, an electronics engineering video blog of interest to anyone involved in electronics design. I'm your host, Dave Jones. $30,000 worth of brand new Tektronix MDO4000 series oscilloscope. You know what we say here on the EEVblog, don't turn it on, take it apart. That back case came off incredibly easily, and here's the flip out feet mechanism. They just use a metal lever bar there, and that works quite well. I like it. And I've got to admit, I'm very impressed with the metal shielding on there, just like in the Agilent ones. It's beautiful. I like it. And you can see the power supply. Well, there's some here's a huge black metal heatsink down in there. The massive fan on the back here, which we'll look at, and very well shielded. I like it. It looks pretty easy to take apart with some Torx screws, so let's give it a go. And there it is. That came apart relatively easily. Quite a few Torx screws and a few jack nuts and the BNC nuts. But apart from that, it came apart fairly smoothly. I was quite impressed. Now, there's actually quite a few rather interesting aspects to the build in this thing. I think it's rather interesting. Let's take a closer look. One of the first things I noticed is the arrangement here of these clamp downs bars for the various heat sinks here. There's each heat sink has got one, so they except for the ones under the bottom here, which are on a lower board down there, and they're rather interesting. They haven't just gone for the thermal adhesive. They've actually gone for these bars. So I'm prodding the that yellow stuff under there, and it's thermal paste, or maybe even thermal adhesive. I don't know what they've used there, but presumably if we try and take off those heat sinks, I don't think we're going to be able to see the chip numbers under there, and they're custom anyway, so I don't think I'll bother to do that. But yeah, it's just rather interesting that they've gone to that much effort to hold them on there. Now, if we take a look at the power supply here, of course it's a top quality one. It's from Emerson Networks. You can see that right up in the top in there, and they're doing all the right things. It's a high quality power supply, as you'd expect. And for the main supply output here, they've soldered those directly onto the board with multiple cables, so they're not mucking around there. They haven't bothered using a connector. Really solid connection. There's a connection down on the main board, of course, and there's a smaller one up here. That's probably for some auxiliary voltage or some power monitoring or something like that. As with the Agilent, there's got to be a feedback button from the soft start circuit to switch this power supply off and on, or at least switch the output off and on anyway. And they've dispensed with mounting hardware here, of course. They're just using some thermal pads here to attach it to the back heatsink here, and same on the top side as well. I find this very curious indeed. There's a second board up in here, which we'll take a look at, and it's got the all the rear panel connectors. But look at this little connector here. It's got two leads coming out, which then go down into the active and the neutral. They're actually heat shrunk. They're actually put inside the heat shrink, and then they go down the active and neutral, and then they actually terminate just here. So they're like a sense to pick up the mains frequency. Is that for the mains sync? I wonder, well, the mains trigger or something like that perhaps? I don't know. It's very interesting. And curiously, they've got this PCI connector down on the main board down there, and it actually connects into the rear panel connector board up there, and it's got the Ethernet and the VGA and the auxiliary coax outputs in the USB and stuff like that. And it's got the USB on the front and the back. You can actually see the ones on the front panel here, and they connect through to the same ones on the back. That's quite a novel technique to actually get board like those USB ones. I would have expected them to just mount them on the main board so that they protrude out the front, but I guess they decided to consolidate it into the same chipset. And once again, the shielding is taken care of with these little spring shield clips down in here, so when you press the two halves of the case together, the shielding meets and makes good contact, and that's how you get good EMC immunity. And down in this corner here, my guess would be that is a JTAG connector. You know, dual row, 10 pins. I reckon that's it. Hack away, and there's some sort of switch there, probably some sort of reset switch. And obviously all of the DC to DC converter stuff for the lower rails is all done on the main board here. There's this huge heatsink. There's probably some voltage regulators on the bottom side of the board there. There's a ton of large inductors there and filter caps. So yeah, that's a dead giveaway. And that circuitry there is obviously for the logic analyzer, dead giveaway. And from the logic analyzer circuitry there, you can see the controlled impedance traces going up to the main device up here with that SD RAM surrounding it. But curiously, that's the only major device on the board which doesn't have a heatsink on it. So obviously it doesn't get that hot. It's obviously a cool processor, or isn't running that quick, and that's a Tech custom one made by National Semiconductor. And my guess would be this one here is the main processor that sort of runs all the operating system and everything, because it looks like all the back panel interface devices with the USB and everything all flow into that. So I wonder what they're actually running there. I don't know. I'd have to take the heatsink off to find out, but that's a bit hard. So we'll have to wait until Tektronix tell us, or live in wonder. And those two labelled firmware flash devices are a dead giveaway. They're right next to the applications processor there. And that huge device up the top there, that's pretty much the biggest device on the board. It's the Big Daddy, and it seems to tie into all those other ASICs on the left hand side of it. And here we have 6 devices which are clearly separated into basically 2 channels. That's why we found that effect when we actually reviewed it. We saw that if you switch on more than 2 channels, then its update performance actually halves. So there's obviously 3 devices per 2 channels. There's, I don't know, one's probably, I'm not sure if they're the ADC on top, because I'm tempted to think that the ADC is down on the bottom board, and that's what those heatsinks down, those 4 heatsinks down the bottom, which actually protrude through the top board, they're mounted down on the bottom board. So I suspect they're probably the analog to digital converters. And down in here, that package down in there is the main 10 megahertz reference oscillator, and that's done by Fox. And they're a big manufacturer of high quality, high stability. In this case, it'd be a very high stability one, very low jitter, that sort of thing. So you obviously need that when you're talking about these sort of sample rates. And up the top here, it looks like we've got some Micron branded, what looks like memory. I can only assume the number is not familiar at all. So, but they are obviously coupled into these heat sunk ASICs up here, so presumably sample memory. And there's the bottom of the main board. Now there's some more of this Micron memory down the bottom here, another buttload of that. And I thought there was a device on this soldered onto this side of the board, another BGA device, but that isn't populated. As the same with the surrounding components there. There's nothing on the top side, no components, no BGA device. So I wonder what that one is. I don't know. There's the rest of your logic analyzer circuitry, and there's your logic analyzer input connector on the front panel. There's some extra SD RAM around here, and really there's not a huge amount else. And there's the back side of all your DC to DC converter circuitry under that heatsink, and you can see the 3 screws on there that screw the heatsink onto the front of the board. And the USB controller is actually on that back board there. It's a SMSC USB 2514. There you go. So it wasn't actually on the front. And that's a rather interesting board. It's a rather unusual construction. And there is there's a battery on there. There's a lithium battery for the time and date. And the fan is an absolute monster. It's a Sanyo Denki one, so they haven't skimped there on the brand. But overall, the cooling's not bad on this. What the fan does is it actually sucks air in from the outside, sucks it in, which then the only way out is to pass across the power supply and the top of the main board, which will be facing down in here as well, and all that big black DC to DC converter heatsink we saw, and out the cage here. So that's not a bad thermal design at all. And I was right on the money with those heat sinks which protrude through to the top side of the board. They're obviously the analog to digital converters. If you look closely in there, you can see the controlled impedance traces coming out of them to these high-speed connectors, which actually connect through to the top side of the board. And of course, they're our front ends, our vertical front ends under the shielded cans, and they're soldered down to the board. So unfortunately, we won't be able to take those off today. And curiously, over here we have a connector which goes nowhere. That's obviously for testing, programming, diagnostic purposes, whatever. And of course, all of the magic, the new RF magic, happens under this huge shielded custom die-cast metal box. Awesome. And for fans of power supplies, here it is. And here's the backboard in closer detail. And you can see those wires coming off that connector and going down into the mains, wiring like that, and then just terminating right there on the end of the just before the connector. And let's have a pan over the bottom side of the main board. Board here looks like a JTAG, once again a 5x2, and the date code 20th week 2011. And behold, there it is. We have the bottom of the ADC board. And you'll notice the serpentine controlled impedance traces running around here like crazy. We have a rather curious device here that obviously has some firmware on it. That's the only reason it'd have that sticker. I wonder what it is. And let's go for a tour of the backside of our ADC. With our BNCs already screwed into there, I won't bother taking those out. There'll be nothing of note under there. And we have that device, which is obviously programmable, maybe some sort of micro or something, I don't know. They're the backside of the BGAs for the 4-channel analog to digital converter. There's 4 separate devices. That looks like some sort of localized power supply for the ADC Probably a low noise supply. What else have we got? Not sure what that sort of stuff is there, just some miscellaneous stuff. Oh, there's obviously a espresso oscillator there, so maybe that's some sort of local oscillator. And we've got a magic can there. There's obviously some real black magic going on under that, and some other miscellaneous stuff. Let's see if we can take off the RF shield. Oh, here we go. This is exciting stuff. This will be pornographic. What's under here? Oh, you don't do a big solid die-cast metal thing like this on an RF spectrum analyzer without having some magic under here. Let's lift the skirt up. Ta-da! Oh, beautiful. Oh, this sort of stuff just brings a tear to the eye. Oh, real RF engineering. It's just a thing of beauty and a joy forever. I'm not an RF guy, so I won't even begin to explain what's going on here, because I'd probably be talking out my ass, really. There's a high filter here and a low filter. Everything on here, by the way, you see is a transmission line. This is serious business, all right? This is absolutely serious. Let's start with the RF connector up here. I mean, that is some dodgy looking soldering. I'm not too impressed with that. I mean, granted, it's onto a big whopping ground plane and it's a big end connector, but I don't know. I expected a bit better than that, but I guess it's good enough. And the connector leads down into this off-the-shelf CAN device. I don't recognise the manufacturer there. It's probably a manufacturer of precision RF components, and there's not much else surrounding that. And that leads down into these devices down here, which then are cascaded like that all the way through down to this bottom circuitry. And here it is, it brings us in, and this is a little transformer there, as you can see, some sort of chip, I don't know, some sort of passive components surrounding it. And then the output of that branches off up here and then splits into your high and your low filter there, which then go across into here. Oh, it's like a little mini racetrack, it's brilliant. And it also splits off down here, which goes all the way over, all the way over, all the way over, through some circuitry there, all the way over to more circuitry over there, and then it splits again and goes all around. Try and follow this baby. Love to see the schematic. I guess the RF fans and all the hams out there are drooling themselves right about now. And when it comes out of there, it goes up here and it goes into this ferrite surrounded some sort of, I don't know, is it some sort of delay line, waveguide? I don't know. I have no idea what that is. Some sort of transformer? Who knows? I got no idea. RF experts will tell me, and tell me how obvious all this circuitry is. One thing I do know though, it's just beautiful. It really is. Oh. And of course, you're not going to get crosstalk with anything with this custom designed huge die-cast shield with all of the traces, all the matching traces cut out of it. Beautiful. That's how you get zero crosstalk and zero interference in a good quality RF spectrum analyzer. And the can we saw on the top side of the board is for this device here, which obviously has to have a cutout in the board. So, well, you can't just let all the magic escape, so you got to shield it on the other side with the can. But apart from that, everything else is shielded by the copper layers of the board and by the die-cast shielding can. And you can bet your bottom dollar that ain't regular FR4 material either. Now the big test, will it actually boot? Let's see. It's going through the motions, it's making the noises, screen's working, but we're gonna have to wait a minute and a half to find out. And look at that, works like I bought one. What were you worried about, Tektronix?